So we are asked to find the coordinates of the local extrema associated with function y. So if you remember, the local extremas occur for values of x where y prime is equal to 0. So we first have to find y prime, or the derivative of y, and that's equal to e to the power of x minus e to the power of 2x times 2, right? By the chain rule. So I'm going to write that as e to the power of x minus 2 times e to the power of 2x. Now I can factor this, right? I can factor e to the x, 1 minus 2 times e to the x. And I'm going to set that to 0. And whatever values of x that makes this function equal to 0 will give me the x coordinates of the local extrema. So the function above is equal to 0 when either e to the x is equal to 0 or 1 minus 2 times e to the x is equal to 0. E to the power of x can never be 0, right? So there's no solution here. Okay, so no solution. And if I rearrange this, e to the x is equal to a half. And x here is equal to ln of a half. Okay. So that is the x coordinate, okay, of one local extrema. It could either be a maximum or a minimum, we don't know. But in fact, we don't care. It's just asking us to find an extrema. Okay. So we're going to plug that back into our original function. So y evaluated at ln of a half is equal to e to the power of ln a half minus e to the power of 2 times ln a half. And from the ln and exponential property, okay, in general, as an aside here, if we have e to the ln a, that is simply equal to a. Okay. So we can bring down the half here. And that right there, the 2 can be put as an exponent to the argument within the ln function. So we have ln of half squared, which is a quarter. And using the same property here, we get half minus a quarter. And half minus a quarter, obviously, will be equal to 1/4. So our local extrema has the coordinate of ln of a half, comma, a quarter. Okay, and graphically, okay, ln of a half is located at negative about 0.7-ish.